All right, let's just jump right in. Permutations and combinations. You know the one I'm talking about, right? It's that chapter that, honestly, even teachers sometimes admit is a real headache to teach. It's famous for being tricky, but today, we're going to crack it wide open.
So what is it about this chapter that's just so infuriating? Well, it's because in permutations and combinations, you can always get an answer. That part's easy. You multiply a few numbers and boom, you feel like you've got it. But getting the right answer, that's a whole different ballgame. It's so easy to miss one tiny detail or accidentally count the same thing twice.
And here's the thing. The secret isn't about cramming a bunch of formulas into your head. It's about learning a specific way to think. So for the next few minutes, I want you to forget the formulas. Seriously, we're going to build the core logic, the mindset from the ground up.
And it all starts with this one idea. If you can truly get this one concept, pretty much every other problem in this chapter becomes solvable. Think of it as the one key that unlocks everything else. It's called the fundamental principle of multiplication, or FPM for short.
Now, I know that definition sounds super textbooky, but hang with me. It's actually way simpler. Basically, every single PNC problem is just a job. That's it. And your mission is to break that main job down into smaller steps or subjobs. Figure out how many ways you can do each little step, and then you just multiply them all together. That's the whole game.
Okay, I get it. That's still a bit abstract, right? Jobs, subjobs. Let's make this real. We're going to use a classic problem to see this principle in action. This is where it all starts to click.
So picture this, a hall, 4 different gates. Simple enough. Now here's our job. A person has to walk in through one gate and then walk out through a different one. That different part is key.
All right, let's use our new FPM mindset here. The main job is to enter and then exit. See? We can break that down. Subjob number 1, entering the hall. How many options do we have? Well, there are 4 gates, so 4 ways. Easy. Now, subjob number 2, exiting. And remember the rule. It has to be a different gate. So no matter which of the 4 gates they use to come in, how many are left to go out? That's right, 3. So 3 ways for the second subjob.
And now for the magic. To get the total number of ways to complete the entire job, we just multiply the ways for our subjobs. 4 ways in times 3 ways out gives us a grand total of 12. And just like that, we've accounted for every single possible path, without having to draw a messy diagram or list them all out.
Okay, awesome. We've got the basic idea down, but, problems aren't always that straightforward. Let's add a little spice. We're going to look at problems with specific rules, or as we call them, constraints. And for that, we need a new layer of strategy. Pay attention here, because this might be the single most important piece of advice for this entire topic. In any problem with a condition, you always start from the constraint. Always. You find the trickiest part, the rule you have to follow, and you deal with that first. Everything else just flows from there.
Let's put this golden rule to the test. Our job is to rearrange the letters of the word triumph. So, 7 letters, 7 spots. But, and here's the big but, we have a major constraint. The 2 vowels, I and U, have to be on the ends, in the very first and very last spots.
Okay, so what does our rule say? Start with the constraint. So let's tackle those extreme positions. For the first spot, how many choices do we have? Well, we have 2 vowels, I or U. So, 2 choices. Great. Now let's jump all the way to the other constrained spot, the very last position. Once we've placed 1 vowel, how many are left? Just 1. So 1 choice for that spot. See that? We handled the hard part. Now we just fill in the middle. We have 5 consonants left for the 5 empty spots. So 5 choices for the second position, then 4 choices for the third, then 3, then 2, then 1. Now, we just multiply all those numbers together and we get 240 ways. Done.
All right, deep breath, because we're about to tackle the single biggest, most common, and most costly mistake in all of permutations and combinations. This is the trap that catches everyone, even when they feel confident. It's called overcounting, and it loves to show up in selection problems.
So check out this exam problem. You've got 2 sections, Part A and Part B. Your task is to pick 8 questions in total, but here's the constraint, and it's a tricky one. You have to select at least 3 questions from Part A and at least 3 from Part B. Now your gut instinct, the logical seeming path, is probably what you see on the left. You'd think, okay, I'll just satisfy the condition first. I'll pick 3 from A and 3 from B. Now I've met the rule. Then I'll just pick the last 2 questions from whatever's left over. It feels so right, doesn't it? But it's dead wrong.
It's a trap. The correct way, on the right, is a bit more work. You have to manually create every single possible scenario that fits the rules. Case 1, what if I pick exactly 3 from A and 5 from B? Case 2, what if I pick 4 from A and 4 from B? You calculate each of these separate, non-overlapping cases, and then you add their results together. So what's the big deal? Why is that first method so wrong? It's because it overcounts. It ends up counting the same group of 8 questions multiple times. Think about it. That wrong method thinks picking question A1, A2, A3, and then picking A4 as part of the leftovers is a different outcome than picking A1, A2, A4 first, and then A3 later. But it's not. When you hand in your exam paper, it's the same set of questions. The order you pick them in doesn't matter. The case-by-case method on the right avoids this pitfall entirely.
So, where does that leave us? Let's bring it all back home. Remember, the whole point of this was to stop just crunching numbers and to start thinking like a PNC pro. So, let's recap what that new mindset actually looks like.
Here it is, your new 4-step PNC toolkit. No matter how scary the problem looks, you start here. 1. Define the job. What are they actually asking you to do? 2. Break it down into smaller subjobs. What are the steps? 3. The golden rule. Tackle constraints first. Deal with the tricky parts right away. And 4. Multiply the ways for each subjob. This simple process. This is the heart of it all.
You see, by focusing on this process instead of just hunting for the right formula, you've fundamentally changed the game. You now have a framework, a key, to unlock almost any problem they can throw at you with way more confidence. So the real question isn't, how do I solve this problem? It's, now that you have the key, which problems are you going to unlock?